Today we're going to be reviewing for your quiz next class that is going to be on sections 6.7, 7.1, and 7.6 graphing. And you will have an assessment next class on the function D standard. I've created two videos. One video is going to be a review for the traditional assessment, and the other video is to have a review of the practice problems for function D so you meet that standard. So that's what this video is going to be on the 7.1 and 7.6 review. So you should have that out. I'm not going to go through all the problems. The answers are going to be on my website. But I'm going to pick some selected problems to go through with you. And then you're going to watch the video on the function D standard. It actually doesn't matter which order you watch these videos in. So you should have, if you need a calculator, get a calculator. And make sure you have a ruler. And if you need to pause, pause. But I'm ready to go. So here's the review. So we have an ordered pair. Sorry about that. We have an ordered pair, 4, 1. And we want to tell whether the ordered pair is a solution of this linear system. Here is our x, here is our y. And I'm going to make this a little bit bigger. Okay. So on this page, I'm not going to do all the problems. I'm going to do number 1 and number 8 and number 13 with you. And then I'll let you do the other problems for homework. Okay, so what we're going to do is we're going to take the first equation and clearly label that we're checking the first equation. And we're going to replace x with 4, y with 1. We're going to check the math. And we get 6 equals 6. So this point, 4, 1, is a solution to the first equation. Now we're going to check the second equation. Because for this ordered pair to be a solution, it must check in both equations. So we have 3, x is 4, plus y, which is 1, equals 11. 12 plus 1, 13 is not equal to 11. Therefore, the point 4, 1 is not a solution. So this is the work that I wanted to see when you're checking things algebraically. We're going to do the same thing for number 8. It says, use the graph to solve the linear system. Check your solution. All right, so here are the two equations. The solution should be where the two lines intersect. It's called the point of intersection. So that is going to be at -1, 4. That's the solution. So I want to make sure that I've found the solution correctly and I haven't mixed up my x and y coordinates. So I'm going to check the first equation. 5x is -1 minus 4 equals -9. Now don't fudge the check. And you know what that means. 5 times -1, -5 plus -4 equals -9. -9 equals -9. So this point checks correctly in the first equation. Now I'm going to check it in the second equation. The y is 4 plus 2. X is -1 equals 2. And 2 times -1 is -2. So 4 minus 2, 2 equals 2. Cha-ching, it checks. Okay, so that's how you check algebraically. The next problem, it says solve the linear system by graphing. Check your solution. Okay, so equation line 1 is y equals 3x. And that can be rewritten plus 0. So my slope is 3. And I'm going to use rise over run, 3 over 1. And my y-intercept is 0. So the y-intercept is at 0. The slope is 3 over 1. You better get a line that looks like that. Up 3 over 1. I like having straight lines when I'm doing this, so I'm going to go down 3, back 1. I'm going to draw the line. Now I have line 2. Here, again, the slope is at 4. So it's 4, 1. And the y-intercept is -1. This one you have to be very, very clear on how you graph your lines. The y-intercept's -1. I'm going to go up 4 over 1, and I'm really happy because this, when I went up 4 over 1, I hit the other line. So that is going to be the solution. You have to still draw both lines. So the solution, and you circle the solution, is an ordered pair. And the ordered pair is 1, 3. I'm going to check this solution in both of my original equations to make sure I've done it correctly. So I'm going to put a little c here for checking the first equation. Y is 3 equals 3 times x is 1. 3 equals 3, and I'm happy it checks. Check the second equation. Y is 3. 4, x is 1 minus 1. 4 minus 1 is 3. 3 equals 3. Cha-ching, it checks. So my solution is correct. It is 1, 3. Now I'm not going over the next 2 problems on this page. Those are for you to do for homework. The answers are on my website. I'll just give you a couple of tips. For number 15, put the equations in y equals mx plus b. These are equations and not inequalities. Okay. And for inequalities, I'm wondering, is it dark for you? For inequalities, remember that if you divide by a negative, the variable, then you switch the direction of the inequality. Don't get confused. These are equations, and that rule doesn't apply when you are working with equations. Hopefully by now you're getting really comfortable with identifying vertical and horizontal lines. When it's x equal, that's going to be a vertical line. And when it's y equals, it's going to be a horizontal line. And don't get confused with inequalities. These are equal signs. So that means that your graphs will have lines that are solid. On to the next page. Clearly show your work if you want full credit. It says 12 were the ordered pair, and we're going to do number 3. The ordered pair for number 3 is -6, -15. Tell whether the ordered pair is a solution of the inequality. Okay, so this has got a greater than. Right. I'm going to plug in the x and the y. 2x is -6 minus, don't get yourself confused, and I would put the y in parentheses so that I do the order of operations correctly, greater than 4. So 2 times -6 is -12. Minus a negative gives me a positive. Plus 15 is greater than 4. 3 is greater than 4 is false. Therefore, -6, -15 is not a solution to this inequality that you were given. Okay, so clearly show your work and clearly state your answer. This ordered pair is not a solution. So now we're going to, the rest of these problems on this page are going to be graphing inequalities. And the first thing to make sure that you remember, all right, it's important. If you have an equal sign, it's a solid line. So less than equal to, greater than equal to, your line is going to be solid. If you do not have an equal sign, your line is going to be dotted. So I'm going to do number 11 with you. 11 is the trickiest of these problems. So what I'm going to do is I'm going to rewrite it here because I'm going to put it into y equals mx plus b. So I have x minus y is greater than -2. I need to isolate y, subtract x from both sides. I get -y is greater than -x minus 2. And this is where we have the difference with inequalities. Here, The variable was divided by a negative number. So y, we must switch the direction of the inequality, is less than x plus 2. You might want to write that note down for yourself. Note. For inequalities, when you multiply or divide the variable by a negative number, you must switch the direction of the inequality symbol. So, for inequalities, when you multiply or divide the variable by a negative number, you must switch the direction of the inequality symbol. All right. So now, we're going to graph this line. The y-intercept is at 2. The slope is 1. Up 1, over 1, up 1, over 1, or back 1. Okay. There's no equal sign. So we draw a dotted line. Then we're going to test the point 0, 0. It doesn't matter which equation you do it in. Okay? You're going to get the same result. So if I test it here, 0 is less than 2. Or if I tested it over there, 0 is greater than negative 2. In both cases, 0 less than 2 is true. 0 is greater than negative 2 is true. So this is a solution. So I shade this side. That, use an arrow to mark, is the solution region. So for questions 13 and 14, make sure that you've got that answer. For questions 13 and 16, the tip is put them into y equals mx plus b. You should notice that this is going to be a vertical line. And 21, you should notice that that's going to be a horizontal line. So that is 6.7, and now we're on to section 7.6, which is graphing systems of inequalities. And I'm going to to let you do these problems, determine whether they're the ordered pairs, tell whether the ordered pair is a solution of the system of inequalities, explain, because on your quiz next class you're going to need to explain what your decision is. But here are the guidelines. Solutions are an ordered pair that is in the solution region. Solutions are the ordered pair in the solution region, which I'll let you abbreviate S period R period, solution region, or they're on a solid line. So all the points on this line are solutions. Points on a dotted line are not solutions. All right, so there's 3 problems like that. The next 3 are matching. I find these always kind of fun. You can figure them out by process of elimination. You had these for your 7.6 homework. So basically you just have to figure out, is this system A, B, or C? And then continue with 5 and 6. The last problem we're going to do together is number 10. Right? Because this is the most challenging one. So we have 2 lines. And so write these 2 lines down. And I'm challenging you here with this problem. We want to get into y equals mx plus b. The y is on the right-hand side. So you know that you're going to subtract 2 from both sides. You're going to get x minus 2 is greater than or equal to y, which we can then rewrite backwards. Y is less than or equal to x minus 2. So that's easy to graph. Okay, the only tricky thing was getting it into y equals mx plus b. So the y-intercept is at -2. The slope is 1, up 1, up 1. There's an equal sign, so it's going to be solid. So you draw that line. And then we're going to test. I want to see what point you pick for testing. Test 0, 0. 0 is less than or equal to -2. That is false. So this is not a solution for the first line. So I shade the opposite side. Okay, now we're going to take the other one. This is easy peasy. We're going to get it into y equals mx plus b. Subtract 2x from both sides. Y is less than negative 2x plus 4. Notice there's no equals, so it's going to be dotted. So our y-intercept is at 4. Our slope is at negative 2. So we can't go up 2, so we go down 2, back 1, down 2, back 1, and we are drawing a dotted line. And now I want you to show the work for testing the point. And 0, 0 is always the easiest point to test. So 0 is less than, that's going to be 0, 4, which is true. So that means that this side is shaded. So our solution region is this area where it intersects, and clearly label that that is the solution region. So now you can work on these problems. Don't forget to go to my website to check the answers. The best way to study for tests and quizzes is to practice problems. Have a nice day from the home of Mrs. Groves.